In this lesson, we will learn how to break up one complex rational expression into equivalent sum of simpler fractions. Let's get started with given rational expression, which is a proper rational expression as degree of the polynomial in the numerator is less than degree of the polynomial in the denominator. So the given rational expression is 2x plus 1 divided by x minus 1 into x plus 2 into x plus 3. As you can see, we have three linear factors in the denominator and none of the factor is being repeated. Now for each linear factor in the denominator, let's assume one constant in the numerator so that a over x minus 1. A is a constant for linear factor x minus 1, and similarly b is a constant for the linear factor x plus 2, and c is a constant for the linear factor x plus 3. So we are in fact converting product to sum. The expression on left side is one complex product of so many different factors, and the one on the right side is sum of the simpler fractions with introduction of the constants a, b, c. Now our job is to find these constants a, b, c. Let's take the LCM on both sides, and we'll have 2x plus 1 equal to a into x plus 2 into x plus 3 plus b into x minus 1 into x plus 3 plus c into x minus 1 into x plus 2. So this is what happens when you take LCM on right hand side and then cross multiply it on the other side. The LCMs on both sides will get cancelled. And now to get value of a, constant a, we are going to substitute the linear factor just below a equal to 0. Substitute x minus 1 equal to 0. If x minus 1 is equal to 0, this means x is equal to 1. So we are going to substitute a value of x in equation 1. So putting this value of x, putting this value of x in equation 1. So we will have 2 times 1 plus 1 equal to a into 1 plus 2, 1 plus 2 into 1 plus 3. Everything else will become 0 because x minus 1 is present in b, it is present in c as well. So plus b times 0 plus b times 0 plus c times 0. So this gives us 3 on this side equal to a into 3 into 4. So the value of a will become equal to, a is equal to 1 over 4. So we have value of a. Similarly, we will find value of b and c. Similarly, for finding b, substitute or put What was in the denominator? X plus 2. So we are going to put x plus 2 equal to 0. X plus 2 equal to 0. This gives us value of x equal to minus 2, and substitute this value of x in equation 1 again. Substitute this value of x, this value of x in equation 1 again. And what is that equation 1? Equation 1 is 2 times minus 2 plus 1 equal to b, because a will become 0, a times 0 plus b into minus 2 minus 1, minus 2 minus 1 into minus 2 plus 3 into minus 2 plus 3, and for c it will become 0. So this way a and b are b is left over and a and c have become 0. So this is minus 4 plus 1 equal to b into minus 3 into 1. So this is minus 3 equal to minus 3b. This means b is equal to 1. This gives us b equal to 1. Now we have value of a as well as value of b. To get value of c, put x plus 3 equal to 0. X plus 3 equal to 0 means x equal to minus 3. And this time we are going to substitute x equal to minus 3 in the entire equation 1. So substitute x equal to minus 3 in equation 1, and this time this will become 2 times minus 3 plus 1 equal to a into 0, because this entire factor x plus 3 is present in a and as well as in b, plus b into 0 plus c, and in c we have, for equation 1, we have x minus 1 and x plus 2. So minus 3 minus 1 into, what is the second, is x plus 2 means minus 3 plus 2. Minus 3 plus 2. So now this will become minus 6 plus 1 equal to c into minus 4, and for the second it becomes minus 1. So this is minus 5 here on left side equal to 4c. So this gives us c equal to minus 5 over 4. Now we have all the values for a, b and c. If we substitute these values of a, b and c in the parent equation, substituting these values of a, b and c in equation, what was the parent equation where we assumed ABC? Here it was 2x plus 1 divided by x minus 1 into x plus 2 into x plus 3 equal to, what was the value of a? The value of a we found was 1 by 4. So that is 1 by 4 into x minus 1 plus b. What is for the value of b? We have value of b equal to 1. So plus 1 over x plus 2, and for c we have the value minus 5 by 4. So this is minus 5 divided by 4 into x plus 3. And here you can see we have converted a complex rational expression on left hand side into simpler expression on right side, whose sum is equal to the expression on left side. And this technique will help us a lot when we will be performing derivatives and integration on these complex rational expressions. Let's do one more question, and here this time the example number 2 is 3x square minus 4x minus 5 over x minus 2 into x square plus 7x plus 10. So if we write this down, given expression is 3x square minus 4x minus 5 divided by x minus 2 times x square plus 7x plus 10, x square plus 7x plus 10. As we described in the case 1, that all the factors in the denominator are linear and they are not repeating. But here we see that there is one factor, x square plus 7x plus 10, which is not linear. It is in fact quadratic. But let's see if we can break it up into linear factors. Since x square plus 7x plus 10 is equal to x square plus 2x plus 5x plus 10, this means this is equal to x into x plus 2 plus 5 into x plus 2 equal to x plus 2 times x plus 5. It means the given expression can be written in the form 3x square minus 4x minus 5 over, this is x minus 2, x plus 2 into x plus 5. So now this given expression takes the form which was described in the start. So let's write this down as sum of the simpler rational fractions. So assume A, B, C such that 3x square minus 4x minus 5 divided by x minus 2, x plus 2, x plus 2 into x plus 5 equal to A divided by x minus 2 plus B divided by x plus 2 plus C, third constant divided by third factor, which is x plus 5. So now we take LCM on right hand side and then cancel it out. So this gives us 3x square minus 4x minus 5 equal to a into x plus 2 into x plus 5 plus b into x minus 2 into x plus 5 plus c into x minus 2 into x plus 2. So now for finding a, for a, put the factor just below it equal to 0, and the factor below a is x minus 2. So put x minus 2 is equal to 0. This means x is equal to 2. So if that is the value of x, then from the equation 3x, okay, this gives us, or this implies that 3 into 2 square minus 4 into 2 minus 5 is equal to a into 2 plus 2 into 2 plus 5, because x minus 2 is present in b as well as in c, so both of them will become 0. b times 0 plus c times 0. This means 3 times 4 minus 8 minus 5 is equal to a into 4 into 10. So this is 12 minus 13 equal to 40, equal to 40a. So this gives us a equal to minus 1 equal to 40a. This means a is equal to minus 1 over 40. So this is value of a, and now we will find value for b. Now to find b, put the linear factor below it equal to 0. What is the linear factor below this? Is x plus 2 equal to 0. X plus 2 equal to 0. This gives us 3 times, so this means our x equal to minus 2. So once we have this value of x, we can put this value of x back in the equation 1. So this is 3 times minus 2 square minus 4 times minus 2 minus 5 equal to a times 0 plus b into, what are the values for b, is minus 2 minus 2. So that would be minus 2 into minus 2 plus 5 plus c times 0. This is alright. So this will give us value for b. This is 3 times 4 plus 8 minus 5 equal to a into 0 is 0. So b into minus 4 into 3. So this gives us 12, and 12 plus 8 is 20. So this gives us 15. 15 equal to minus 12b. So the value of b this way we obtain is equal to 15 over minus 12, and if we divide it on 3 in the numerator and in the denominator, b is equal to minus 5 over 4. So we got the value for b. Now we will find out value for c. Now to find value of c, this time we are going to put the linear factor just below it equal to 0, and that is x plus 5 equal to 0. X plus 5 equal to 0. This means x is equal to minus 5. So if that is the case, then we'll have 3 into, this means 3 into minus 5 square plus minus 4 into minus 5 minus 4 into minus 5 and minus 5. Minus 5 equal to a into 0 plus b into 0 plus c into, what are the factors? One is x minus 2 and x plus 2. So that would be minus 2 and plus 2. Alright, so this will be minus 5 minus 2 into minus 5 plus 2. So this way we will have value here 3 times 25 plus 20 minus 5 is equal to c into minus 7 and minus 3. So 75, 85, 95 and 90 on the left side. 90 is equal to 21 c. So this gives us c equal to 90 over 21. Substituting value of c, b and a in equation number 1 here. Well, this was 1, so let's call this as 0 equation and call this as equation 1. So substituting values of a, b and c. Substituting values of a, b and c in equation 0, we got 2x squared minus 4x minus 5 equal to, okay, here what is, this is 3x squared minus 4x minus 5. So this is 3x squared, 3x squared, okay, equal to minus 2 equal to, so this is minus x minus 2 and this is x plus 2 and this is c is plus 90 over 21 into x plus 5, and what is b? B is minus 5 over 4. So this is minus 5 over 4, and a is equal to minus 1 over 40. So this is minus 1 over 4 0. So these are okay here, and on the left hand side this is x minus 2 into x plus 2 into x plus 5. So this is how we perform partial fractions for given proper rational expression. Again, by proper rational expression we mean the degree of the numerator or the degree of the polynomial in the numerator is less than degree of the polynomial in the denominator.